Hey guys, we get to start the appendix today, and the first one is on Venn diagrams. Um, so it's not your mama's Venn diagram from English class or whatever. It's going to be a little more in depth. We're going to be talking about sets of things, um, and I've broken it down to a couple of days of instruction because it's a pretty lengthy one. In discussing sets, it is convenient to refer to a general set that contains all elements under discussion. This set is called the universal set. A universal set, which is symbolized by the capital U, is a set that contains all the elements being considered in a given discussion or problem. We can obtain an understanding of sets and their relationship to a universal set by considering diagrams that allow visual analysis. Venn diagrams are used to show the visual relationship among sets. Okay, so we're going to use this Venn diagram to determine each of the following sets. So notice the box is the universal set. So that's everything that we're discussing. And the discussion is a square, a triangle, a dollar sign, a capital M, and a 5. And you'll notice the circle here, this is denoting, this is what's in set A. Okay, so the first question is, what is in set U? So we're going to use set notation. So it's going to be U with the brace equals the brace. So what are the things in discussion? I just went over them. It's the square, it's the triangle, it's the dollar sign, it's the M, and it's the 5. Okay. Number 2, what's in set A? So again, A is, what's in A? Just the square and the triangle. Set A is the square and triangle. And then number 3, the set of elements that are in U that are not in A. So that would be the other 3 things, right? I forget how to write U not A. Don't worry about it right yet. What's in U not A? It would be these 3 things: the dollar sign, the capital M, and the 5. Okay. Now we're going to give you some vocab here. So there are a number of different ways, excuse me, to represent 2 subsets of a universal set in a Venn diagram. To help understand these representations, we're going to use this scenario for each of our examples. You are determining whether there is sufficient support on campus to have a blood drive. You take a survey to obtain information asking students: 1, would you be willing to donate blood? 2, would you be willing to help serve a free breakfast to blood donors? So A is going to represent the set of students that are willing to donate blood, and B is going to represent the students who are willing to help serve breakfast to donors. Okay, so here are some possibilities. 1, you could have what's called disjoint sets. That's 2 sets that have no elements in common. It would look like this: no overlap of the circles. So in that scenario, this would mean that no students willing to donate blood are willing to serve breakfast, and no students who are willing to serve breakfast are also willing to donate blood. So that's called a disjoint set. There's nothing in common in set A and B. The next one is called a proper subset. Set A is a proper subset of set B, which is this symbol. So A is a proper subset of B. All elements of A are in B. So in our scenario, all students willing to donate blood are also willing to serve breakfast, but there are other students who are only willing to serve breakfast. The next one is called equal sets. Equal sets look like this. If A equals B, set A equals B, then set A contains exactly the same elements as set B. So in our scenario, all students who are willing to donate blood are also willing to serve breakfast, and all students willing to serve breakfast are also willing to donate blood. So they're the exact same group of students. And then the last one, this is your more typical Venn diagram: sets with some common elements. So in mathematics, some means at least one. We're just defining that. So if set A and set B have at least one element in common, then the circles representing the sets must overlap. In our scenario, there are some students only willing to serve blood. That would be over here. There are some students only willing to serve breakfast. That would be over here. And then there are some in common who are willing to do both. In all likelihood, this is a representation of our scenario. Now note the fourth region. Notice there's other space out here. What does that represent? That represents the students who are not willing to donate blood and also not willing to serve breakfast. So remember, there's always others out there. Okay, so what we're going to do is we're going to look at a beautiful picture. I've got the regions noted, region 1, region 2, region 3, and region 4. So those aren't parts of the discussion. That's just kind of the regions to match up here. And then we're just going to answer some questions on this. Okay, so first question is, what's the set U? So that's what's everything in discussion. So we'll use U equals brace. So what is everything we're talking about? Well, that'll be the letters A, B, C, D, E, F, and G. That's everything in discussion. A, B, C, D, E, F, and G. Those are all of the elements that we're talking about. Now, what belongs in set B? In set B, notice B is this whole circle. So some students might say, oh, just E is in B. No, what's in set B? That's this whole circle. D and E are in set B. Okay. Number 3, the set of elements in A, but not in B. So the set of elements that are in A, but are not in B. So A is all of these. Which of these are also not in B? Well, D is in A and B, so we can't include that. So things that are in A, but not in B would be just these 3 over here, A, B, and C. And again, I don't remember how to write that, so I'm just going to write the braces, A, B, and C. The set of elements in U that are not in B. So what's everything in U? All of these. What's not in B? These 2 things are in B. So what's in U but not in B? A, B, C, and F and G. A, B, C, F, and G. Okay. The set of elements in both A and B. So it's not what's in A and B, it's what's in both A and also in B. There's only one. That's this region right here. Both A and B is D. Okay. Next page is called, so again, just lots of vocab today. The next thing is called the complement of a set. In arithmetic, we use operations such as addition and multiplication to combine numbers. We will look at 3 set operations, which are called complement, intersection, and union. So these are operations like adding, subtracting, multiplying, and dividing. So let's see. The definition of the complement of a set. The complement of a set, symbolized with A with the apostrophe, so that's the complement of set A, is the set of all elements in the universal set that are not in A. This idea can be expressed in the set builder notation as follows. So this says the complement of set A is the elements such that that element is in the universal set and is not in set A. Okay, so the shaded region represents the complement of set A, or remember A with the apostrophe, much easier to write. This region lies outside circle A, but within the rectangular universal set. So the blue section here, that is the complement of set A. So this is what's in A. The complement is everything that's not in A. In order to find the complement of A universal set must be given. A fast way to find the complement of A is to cross out the elements in U that are given to be in set A, and then the complement of A is the set that remains. So that's the quickest way to do that. Okay, so let the universal set be the numbers 1 through 9. Set A is the numbers 1, 3, 4, and 7. What would be the complement of A? So again, the fast way is just cross out 1, 3, 4, and 7. Since those are in A, then the complement of A would be the things not in A. So the complement of A would be the things left over. 2, 5, 6, 8, and 9. And then they ask us to draw a Venn diagram of that scenario. Okay, so we're going to start with a rectangle. We'll denote it as U. And then we need a set A. Okay, so what's in A? A has the numbers 1, 3, 4, and 7. And then the other ones are just somewhere outside of A, but in the box. 2, 5, 6, 8, and 9. So there you go. We drew a Venn diagram. All right, the next one, the next vocab is the intersection of sets. So if A and B are sets, we can form a new set consisting of all elements that are in both A and B. This is called the intersection of two sets. So the intersection, here's your more formal definition. The intersection of sets A and B, written like this, the intersection of A and B, we've seen that symbol before, is the set of elements common to both set A and B. This definition can be expressed in set builder notation as follows. The intersection of A and B is the set of X such that X is an element of A and X is an element of B. Okay. Find and draw the following intersection. So this says, what's the intersection of these numbers and those numbers? So that is what is in common in both of these. So let's see, what's in both? I see 8 is in both, I see 10 is in both. So the intersection of those two things would be what's in common, 8 and 10. Okay, so we found the intersection. Now let's draw that. So we just really need two circles. And it's easiest when you're drawing these pictures to start from the middle and work your way out. So what's in both of them? 8 and 10. And then over here to the right would be the other numbers that aren't 8 and 10, so that'd be 6 and 12. And then on the left side are the numbers that are not 8 and 10, so that'd be 7, 9, and 11. So there's that intersection. Okay. Here, same thing. What's the intersection between 1, 3, 5, 7, and 9, and 2, 4, 6, and 8? Well, I notice these are odd numbers, these are even numbers. What is the intersection? Is the empties. There is no intersection, right? There's no numbers in common in both of those lists. So what would that look like as a picture? This would be two circles that have nothing in common, so they would have no overlap. And then we just put the numbers in there. 1, 3, 5, 7, and 9. 2, 4, 6, and 8, and that one. Okay, this says what's the intersection between these odd numbers and the empty set, which is nothing. Well, what's the intersection between odd numbers and something that has nothing in it? Nothing. There's nothing in common with nothing and some numbers. So what would that look like? It would just be one set. 1, 3, 5, 7, and 9. If you wanted, you could draw a second set with nothing in it. Okay, and the last one, union, we've seen this before as well. It's like intersection. So another set that we can form from sets A and B consists of the elements that are in A or B or in both sets. This is called the union of the two sets. So the union of sets A and B, written the union of A and B, is the set of elements that are members of set A or of set B of both sets. This definition can be expressed in set builder notation as follows. The union of A and B is the set X such that X is an element of A or X is an element of B. So we can find the union of set A and set B by listing elements of set A. Then we include any elements of set B that are not already been listed. And then be sure to put your answer in braces. Okay, here's your hint. When finding the union of two sets, some elements may appear in both sets. You list these common elements only once, not twice, in the union of sets. You can't really draw a picture of these, that's why I don't have pictures. Okay, so here's how you do it. To find the union, we're going to write all of the numbers in the first set. 7, 8, 9, 10, 11. Okay, and then anything that we've already covered, we're not going to write again. Anything we haven't seen before, we're going to include. So 8 and 10 have already been covered, so we're also going to include 6 and 12. Really, it's best to put this in numeric order, but this is okay as well. Okay. The union of these numbers and those numbers. So again, very simple. 1, 3, 5, 7, 9. And then none of these have been covered either, so we just write them as well. It's all of them put together. Last one, what's the union of the odd numbers with nothing? So again, the one up above was nothing, but this one, because it's union, is, well, there's a 1, a 3, a 5, a 7, a 9. There's nothing else added to that, so that's just what it stays as. That's it. So let me know, lots of vocab today, so get comfortable with those words. Make sure you read those over a few times. Let me know if you need any help with anything. We'd be glad to help you out. You do have a My Math Lab assignment, so good luck on that. Let me know if you need any help with anything, all right? We'll talk to you soon. Y'all have a great day. See you later.